Okay, so yesterday we talked about just figuring out which one's the null hypothesis, which one's the alternate, the ho and the ha. I just shortened them to the ho and the ha, just so you all know. 10.2 is all about what kind of error you can make. So you have to be able to say what could happen if something goes wrong. So there's obviously still the two forms of hypotheses. Basically what you do in this situation is you use sample data to decide whether or not to either reject our null hypothesis or fail to reject. So just like a jury can reach the wrong conclusion, you can always reach the wrong conclusion when you're doing a test. So there's a little table you got to draw. So that's what we're going to talk about today. What happens when things go wrong? So you either think the null hypothesis is true or the null hypothesis is false. Okay, this column is the truth based on the population. So either it's true or it's false. So whatever you're trying to study. But in this class, we can't look at the whole population. We always look at a sample. So we can either reject the null hypothesis or we fail to reject the null hypothesis. And these are both based on a sample. Okay, so when inference is all making a conclusion based on a sample. Now, so there's two things that are good, two things that are bad. The two things that are good is when you reject the null hypothesis when the null hypothesis is false. So if you put a little smiley face, that's a good thing. This is the right conclusion for the population based on the sample. When you reject it when it's false. The other one is when you fail to reject the null hypothesis when it's true. So put another smiley face there. Those are your two good conclusions. Like convicting a guilty person, letting an innocent person go free. Those are your two good conclusions. There are two types of error. We were very creative and we named them type 1 and type 2. So type 1 error is when you reject the null hypothesis when it's actually true. That's type 1 error. So when you reject the null hypothesis when it's true. Type 2, and this is how I remember it, we fail to reject, that's type 2, when it's actually false. So if you remember this little table, it'll help you remember error. That's all this stuff says down here too. Type 1 error is when we reject the null hypothesis when it's true. Type 2 error is when we fail to reject, that's why I always think about it, when it's actually false. So you're going to have to write out the error in a normal sentence in the context of the problem. So it'll ask you, a lot of times they'll say, okay, describe type 1 error, describe type 2 error. So let's try an example to figure out which one's which. So a machine is set to produce bolts with an average diameter of 1 centimeter. Every hour a sample is inspected and the machine is adjusted if there's convincing evidence that the average diameter is not 1 centimeter. State the hypotheses, describe both types of errors for this testing procedure. So first thing you always want to figure out is what's your ho and ha. So our null hypothesis, remember from yesterday, is always an equal. So for here it should be that mu is equal to 1. That our bolts have a diameter of 1 centimeter. Our alternate is that mu is not equal to 1. We don't care if it's greater than or less than, we just want to know if it's not equal to. So for type 1 error, and for some reason, maybe it's just me, this is always really tough for me to think about. I have to like read the sentence out loud to myself, then like think about what it means in the context of the problem. So type 1 error is rejecting the null hypothesis when it's actually true. So we're rejecting this, but it's actually true. So this is like saying the diameter of the bolts is not equal to 1 centimeter when it actually is equal to 1 centimeter. So again, rejecting the null hypothesis when the null hypothesis is true. So saying it's not equal to 1 centimeter when it actually is equal to 1 centimeter. Okay, when I ask you to describe type 1 error and type 2 error, like on the quiz and the test, I don't want you to just repeat these sentences. That's why it takes a minute. I always have to like think about it. Type 2 is the opposite. So we fail to reject the null hypothesis when it's false. Now this one's like a double negative. So you're basically saying this is true when it's not. So saying the diameter of the bolts is equal to 1 centimeter when it actually is not equal to 1 centimeter. So they're opposites. Going back to geometry, they're converses of each other. Okay, so make sure whenever you do this that you try to put it in the context of the problem. And then make sure you clearly contrast the decision with the reality. So not equal to equal. Okay. Now, type 1 error and type 2 error have symbols, because obviously we don't always like to use words. Type 1 error is alpha, and it's also called the significance level. Okay, type 1 error is going to be very important when we start talking about hypothesis testing, which we'll do in like 2 days. Okay, so type 1 error is always alpha. The type 2 error is beta. It's like a Greek letter B. So alpha, beta. Okay. And we'll talk about more about these in a second. So another example that we'll use a lot in terms of like error and stuff is pregnancy. So a pregnancy test is designed so it will correctly detect pregnancy 99% of the time and correctly determine that a person isn't pregnant 90% of the time. If the null hypothesis is not pregnant, describe both errors and find their probabilities. So for me, it's always helpful to make sure I write out the ho and the ha. So again, our null hypothesis is that you're not pregnant. Remember, that's what you're assuming to be true. Although I don't know why you take a pregnancy test if you think you're not pregnant. Whatever. The alternate, again, would be that you're pregnant. So, type 1 error, again, rejecting the null hypothesis when it's actually true. So, telling someone they're pregnant when they're not. So, telling a woman they are pregnant when they are not. So the alpha level here, so if it determines that a person is pregnant 90% of the time, or a person isn't pregnant 90% of the time, that's our alpha. That means I have a 10% chance that I'll get basically a false positive. False positive. I don't like to use the words false positive and false negative because sometimes it depends on what you think the ho and the ha are. Depending. Okay, so our alpha levels is 10% because it's a 10% chance of a false positive. Type 2 is the opposite. Telling a woman they are not pregnant when they are. And if they can correctly detect a pregnancy 99% of the time, that means I have a 1% chance. My beta is 1%. Okay, we got to talk about, this leads into the fact that you want to minimize both of these when you're doing tests. So, go to the next page. We want to minimize both these errors. Obviously, we would like to have alpha 0, beta 0. You would like a pregnancy test to be 100% positive, or 100% accurate, I should say. But that can't really happen in the real world. So when we're conducting tests, the only thing we can change is our significance level. We don't have really control over beta, but we can control alpha. So here are your three options for alpha. 0.1, 0.05, and 0.01. Okay, those are our three options for alpha. Sometimes in the problem, they will give you alpha. Sometimes they won't. What do the three alphas mean? So an alpha 0.05 means if we're using a testing procedure that will make a type 1 error only about 5% of the time. So if we were to take many samples and perform many tests, about 5 out of every 100 would reject the null hypothesis when it's actually true. It kind of relates to confidence interval. We'll talk about that later. But it's similar to a confidence interval. You're giving yourself like this, like margin of error almost. Decreasing one type of error causes the other to increase. So if I decrease alpha, I have to increase beta. Alpha is the only one you have control over. You have three options. There's obviously more, but I don't think you would want more than a 10% chance of being wrong. Otherwise, why are you doing what you're trying to do? The only way to decrease both types of error is to increase the sample size. Because you'll have a good, cross-section of the population. Obviously, there's always a risk for one of these errors. So how do you figure out which alpha to pick? Like, a lot of times the problem will give you an alpha, but I can always ask you to pick one. So here's what you do to pick an alpha. You look at the consequences of the type 1 error and the type 2 error. Then you identify the largest tolerable alpha for the problem. Employ a test procedure using the minimum acceptable value of alpha as the level of significance. Basically what we're going to do tomorrow and Friday is we're going to find a probability. And if the probability is smaller than your alpha, you reject the null hypothesis. So I'm kind of giving you the pieces of a write-up this week, and then on Friday we'll do a full one. So remember yesterday we talked about the judicial system? Right? Our null hypothesis here was that the person was not guilty. Your alternate was that they were guilty. So alpha here has to be low. We would rather let a guilty person go free. Letting a guilty person go free is type 2 error. Then convict an innocent person. Convicting an innocent person is your type 1 error. So obviously type 1 error is considered worse. So you're trying to figure out which one's considered quote unquote worse. Whatever error is worse, you want the lower level. So since type 1 error is worse, we're going to pick a low alpha. Okay? Because then beta is higher. And letting a guilty person go free is not as bad as convicting an innocent person. Does that make sense? For our pregnancy test, it's the opposite. Beta should be low. Because if you look at your two types of errors, telling a woman they're not pregnant when they actually are would be considered, I think, worse. Right? Because they may go out and do things that are not good for the baby. Than telling someone they are pregnant when they're actually not. Just in terms of health. So since type 2, this is type 2, to be pregnant and not know it. Type 1 is you think you're pregnant when you really aren't. That's type 1. So since this one's considered worse, and that's why I said I use quotes, beta should be low. So then you'd pick a high alpha, like 0.1. If it doesn't really matter, you don't think either one's like worse, like we'll do an example about like how much weight you can put on a chair, right? Doesn't really matter if you let somebody break a chair or not. Then you pick the medium alpha, which is 0.05. So if you don't think either one's worse, then you just go with the middle. So extraordinary claims require extraordinary evidence. Smaller values of alpha should be used to test claims that don't have much supporting evidence. Okay, so just think smaller the alpha value, the more evidence needed to reject our null hypothesis. Because this is what we're assuming to be true. Questions. A lot of this is like conceptual. Big thing you should get out of today, can you write your two types of errors and can you pick an alpha?